Hi, my name is Abu Francis, and I'm continuing this series on falling in love with architecture. In an earlier video, I had spoken about something called the problem space. The problem space is that part of your inquiry into your project which explains like what is the problem which you are really dealing with. Now, I'm going with the assumption that you are clear about the fact that architects solve problems and real problems, people suffering somewhere, something, and that is what we are really engaged with. And I had recommended, if you recollect, that we need to move from the problem space to the solution space and never get confused between the two. What I mean by solution space is that for a particular problem, especially in architecture, there will be many different ways to solve the same problem. That's why in a class of 60 people, each person would be coming up with his or her own design for the same project. So it's not actually 60, it will be 6 million different things you can do for a particular architectural project. And that's why I always say that architects are the trained inventors. We are the only field where we are been taught to invent, because invention is something which was never there before, right? So every building is an invention, and we need to wire our brains in such a way that that invention really happens in a nice manner. I'd also mentioned in an earlier video that it is really very tough to criticize architecture after it is already built, because what's the point? I mean, you can't stand in front of it with a remote and change that building, right? So whatever you need to do, you have to do when you are actually sitting down and thinking about that particular problem. So I'd given this theory that, okay, we have a problem space and then you have a solution space. And what really happens is you move between the problem space and the solution space, and you keep spiraling around between these two areas to come up with the final solution. So some of you asked, what is the problem space? How do you define the boundaries of the problem? Solution space, I just explained, there can be many different solutions. So for each solution, you can put a dot on it, and then you can come up with a particular theory about that. So that's one solution. There's another solution, and all these dots represents that solution space. So this is solution space. But what is problem space? What is problem space? How do you know that you have actually explored the problem fully? And that's a very interesting and very important point. Connected to this, there is another thing which a lot of students do not really understand, which is why do we have so many different subjects in our field? I mean, I've seen students getting confused. Do you really need to learn structure? I mean, structural designer will do it. Why should we design structure? Why should we be worried about? Should we? I mean, there are so many subjects, so many topics which we need to be experts in. And architecture in India, at least, is a 5-year course, and all the other this thing is a 4-year course. And there are some discussions that no, architecture should also be a 4-year course. My opinion is, don't hit me for that, is that architecture it should be at least 8-10 years. In fact, we are continuously learning. There's lots of things to be learning. We need to learn for years and years. There is no way by which an architect can say that, okay, my learning is stopped, this is all what I have to do. So why do we have these topics? So the reason is that these topics are needed so that you are sure that you have really explored this particular problem. Have you really explored it? How do you get to grips with it? Now, talking about getting to grips with something, think of a box. And this is a very nice metaphor, actually. It was given by Descartes. Descartes was one of the mathematician, philosopher, and quite an excited guy, but he had one problem, that he used to always fall ill. I mean, his health was not in a good shape. So he used to be sitting in his bed and staring at the ceiling. And one day he saw one fly on the ceiling, and that is where the Cartesian geometry got invented or discovered, whatever you want to call it. Some mathematicians think that mathematics is an invention. Some mathematicians think that mathematics is a discovery, but that's a different subject. So he said that, okay, if you have this particular ceiling and this is where the fly is, so you can actually measure off this much distance from here and this much distance and locate that particular fly. And that actually became a very useful metaphor, to the extent that it actually got overused and it led to a type of philosophy known as reductionism. Anyway, let me not go into that part. The part which is useful is that if you want to come to grips with now what I call as a problem space, you think of it as what could be the way by which I can increase the dimensions of this particular box. Because there will be X, Y, and Z, right, to represent the volume of a box. So if you want to come to grips with a particular box, the bigger the box, that means you have the better chance of what you say covering a bigger volume, right? So what are these X, Y, and Z axis in this particular problem space, just to get you comfortable? This will also actually help you understand where in this whole map of things do the subjects of architecture fit in. Where does all these topics fit in? We are told that you have to learn structure, you have to do basic design, you have to do geometry, you have to do history of architecture. I mean, it just goes crazy. So that's a very, very interesting situation that here is an architecture student who just enrolled, and there's a flood of subjects which she has to now learn. And she's trying to figure out, where does it all fit in? Why do we have to learn all this? The main reason why I have to learn it is because we have to be very accurate about what is the problem space which we need to explore, and we need to understand these three axes which is there. Before that, a small digression. Here's a beautiful project. It's a very old project, and it's now one of the, I think, the National Heritage or a World Heritage site. It is called Mesa. It's in USA. And this is where the ancient Red Indians, they lived in this particular set of houses, which is actually built into a very large cave, which is on the side of that particular canyon. Now that's really, really, really very interesting. So here is a canyon. Here is that canyon over there. And in that canyon, there is this particular cutout. So I'm drawing a section here. Okay, so this is all mountain here. And there's a natural cave, huge cave, which is where all these buildings are made. What was fascinating is that they located this particular, they selected this cave. I assume that it's a pretty large canyon, and in that canyon there must have been many other caves also, but they located this particular cave because it had one unique property, that in winter it will receive the sun directly and everything here will be lit. This is where the sun is. And in summer, the sun goes overhead, and this lip of this cave, it used to protect that, and this part remains in shade. So when it becomes really hot, the sun is not inside the cave. When it is quite cold in the winter time in US is quite cold in that part, and that time the sun is actually getting inside. So this is a very nice example of how in the olden days, how people used to be so sensitive to the world around them, and they used to sit and think about, okay, where should my children and their children and their grandchildren and my grandchildren, I mean my whole generation of people, where will they stay? And they actually sat down and figured out, okay, that's a cave where I will go and stay. And that is actually an act of understanding the problem statement. Which is the problem in which you are staying? What is the situation here? Next, one more curious situation here is, this is something which everybody asks, like, what would be that best design which I have to make for this particular project? And many people will say, oh, my building should look like this and my building should look like that. And the moment you get a design and problem, a lot of students, not just students, okay, a lot of architects also do this. They will just simply jump from the problem statement and they'll directly start visualizing the solution. And they come into the solution space and bhaad mein gaya, like this problem statement, we'll figure out some problem is there. But this is going to look very exciting. Why? Because this is the one which drives all of us. We want to be the best designer. We have to come up with the best design and so on and so forth. But the thing is, you have to hold your horses. You have to really sit and understand what the problem is. Not that you will not move from problem space to solution space. It's natural. We are very excited people. We are creative, right? All of us are creative. And that's a different subject, actually. Not just architects. Everybody is creative. So we want to really come up with a solution. So we'll jump from the problem statement. Here is somebody's trying to explain, this is the project, this is the land, this is the volume, this is the background volume of space which is there, and that space is really rare. So you better be all that, and your mind is already sparking into the solution. But wait, when this happens, I have to tell myself, it happens with me a lot, it happens with all architects. Many architects just succumb to it and they directly start sketching out and they'll come up with a solution very fast. But the real joy of understanding and doing architecture, remember I told you something about empathy. And to understand the problem space, you have to really understand how do you become empathetic to whatever which is happening in that problem space. And so let me summarize. I was telling you about problem space. Then I said that, we need to understand the three axes of that particular problem space and make that axis as big as possible. Then I told you about the various subjects which are there in architecture and how architecture students, they get confused and they do not know why they are learning all these different subjects. So they're all actually related. And now I'm trying to tell you, how do you really enjoy getting into the problem which needs to be described, and what are these three axes? So the three things, and by the way, why did I give that Mesa word as an example? Because you will notice it very soon. So the three axes which you can start with, now three axes is because that's visualizable by human beings. Actually, philosophy says there can be many more axes than just three, and but you can't visualize it. So right now let me start with three, but later on when you become really a big architect, you will start thinking about many other angles of explorations, but let me not confuse you for now. For now, let's start thinking that, okay, this problem space is like a virtual imaginary box, and you need to make that box as big as possible in your mind so that you know that you've actually covered a lot of points. So what are these axes? Okay, more confusion. So the axis is R, rather. I keep confusing my E's and R. One axis is the user or users. Very rarely you'll get just one user in that particular project. In fact, I don't think it's ever there possible. The other side is site. The other axis, you need to know about the site. And the third axis is about the environment. Now, or somebody will say, well, that is also site, right? No, this part of the environment I'm talking about everything other than the site, like things like climate. Okay. Climate mainly, basically. Okay, but you can also include things like ecology and all that. You could include that here also. So these are the three axes along which you have to ask yourself, am I being empathetic to that situation? Do I know enough about the users? Do I know enough about the site? Do I know enough about climate? Do I know enough for me to really, are my hands really, really entwined inside that particular situation there? Is that what I'm going to do? This is something which you have to really ask yourself, and you have to check for yourself that do you know enough about this. Of course, when you're doing all this, your mind will start going somewhere else and slip into a solution space mode and start imagining and sketching out. I'm not going to stop you on that, but you have to tell yourself, okay, come back, let me see whether I know enough of this. Sometimes actually doing a small little solution, working out a model or sketching out something may be pretty useful, but don't get stuck there. Come back and ask yourself, like, I asked some questions and I found certain contradictions in what I'm trying to do. So let me come back and explore that further. So Now let me stitch up another point which I had explained earlier, which is about why do we have so many subjects. And the reason is like this, that if you really look at these three axes, so here I'll call it climate, here I say site, and here I'll say users, you'll find that practically all the subjects will be somewhere around these things. So under climate, you'll have climatology, and you will have under site, you will have site itself, you'll have building materials, the subject called building materials. That is also to do with the sites, because when you dig up that particular site, you're going to use the material. Ideally, you should, or you should be aware of the topsoil which gets removed because the building is coming up there, but that can be an ecological disaster. So you have to figure out what to do with the topsoil so that it comes back again. So that's all to do with building materials. The same soil can be used, or the stone can be used to make that particular building which gets dug out of that site. So building material is there. You have even structure comes in over there, strangely enough, because you may have a natural formation like that in a Mesa word, like that particular site had a natural formation and they use that, so you don't have to build that particular, say, the roof of that particular building or the set of buildings over there, because the roof of the cave is already serving that purpose, so that is already built over there. Or they don't have to use that kind of material which needs to really be strong enough to brace for the wind and breeze and all that, because it's pretty sheltered cave over there. So you have building materials, you have structures. Under users, this can be further divided into things like history, culture. These are all the subjects which we explore actually, and psychology, sociology, and you can go on and on. For users, there is a lot of things which our subject needs to deal with. Under climate, there can be further subdivisions on macroclimate at the large level, what happens, then microclimate at the small level, what happens to the climate. I mean, there are many other things which happens at these levels. So you can actually later on, once you start understanding that, okay, you need to get into all these subjects, and instead of sitting down and rebelling that, why should I learn mathematics? Okay, where does maths fit in? Maths fits in everywhere actually in this. Strangely enough, for people who thought that architecture is not having any maths, let me surprise you, everything is to do with maths here. If you really want to do a good job as an architect, you cannot avoid maths. In fact, traditionally, a lot of architects are really good they become good at two things. One is called linguistics, and the other is mathematics. And related to maths is music. Maths has got a very interesting relation with music. So you'll find that architects become, as a byproduct, they get involved in all these three subjects as they get older. And the reason they do that is because this particular subject, and as your explorations for these particular three axes, if they get into, you need to get to in depth about building materials, what are the qualities of. You'll see intersections also. Building material as related to climate, certain things exposed to heat may crack up. Okay, you under climate, you under site and climate, you'll have things like ecology. You will have things like water harvesting. I mean, there are millions of things which are actually separate individual subjects which needs to be really understood. So you'll talk about sustainability. So you can say both this, climate and site together, is all about the natural situation which is there. And users are the people who are coming there with their problems, what they want to achieve, their life goals, their short-term goals, their long-term goals. All this you really need to be involved in, and you need to be very, very engaged with that particular problem space. It's like getting your hands dirty in all these particular area. And remember, you are still wanting to do a good job as a design, right? But then and so your attention will keep getting diverted from one thing to the other, and you'll go between the problem space and the solution space. You'll keep vacillating between the two, and many people will get stuck directly into the solution space. Many people also get stuck into this problem space. They go into an analytical mode. It's called analysis paralysis. Analysis paralysis. That also should not happen, because that also is a bad situation. You don't have any design. You just got a lot of ideas about, how the climate is and how the weather is and how the breeze is and how the macro climate is and but you don't have any design. So that's also pretty bad. So you need to balance between problem space and solution space. But many times people really do not do enough justice for the problem space. They hurriedly go into the solution space, and then finally turns out that even in the solution space they're not really exploring. They are supposed to explore even in the solution space multiple things, but that doesn't happen, and you end up. So ideally, a design process is a spiraling process where you need to really start, broadly this spiral is between the problem space and the solution space. But there's this very nice book called Inquiry by Design, where this author John Zeisel, he comes up with this particular diagram or version of that diagram, and he says that if you have to design, you have to be very inquisitive. You have to inquire into the design. So he establishes 3 phases in each design, and this is a really nice model. I use this not just in architecture design, it's actually used even in software design. In software design, this process is called the Agile process. It's really very curious that software people came into the architecture field, picked up concepts from architecture, they're using it, but we architects want to go under the illusion that we're very creative, we don't have to explain anything, and we'll just come up with a design. Whereas there is a system, and the system is be engaged in these 3 parts. So what are these 3 parts? So this is called conceptualization, where you conceptualize. Now this word concept is misunderstood. I'll explain what is conceptualization more in detail as a separate topic by itself. Then you have what is called as visualization, where you actually put it down. Conceptualization is all these things will generate something central which you want to now preserve. As you keep vacillating between the problem space and solution space, this concept becomes clearer and clearer. As you move ahead, this concept here and this concept here, this concept will be a lot more clearer than what it was here. Then you end up making drawings or some kind of visualizations. So you can say conceptualize. Let me stick to the letter C. You can say create. Create doesn't mean the actual building. Create drawings or create models or computer diagrams or whatever. And then criticize. This is very important. You have to brutally sit down and look at whatever you have created and ask yourself, are there any internal contradiction on those 3 axes which I came up with? Users, site, climate. Are there any internal contradictions? You have to criticize that. You have to get outsiders to come and criticize that, and then you'll come up with the next cycle, and then the 3rd cycle and 4th cycle, and you'll keep spiraling like this. Now the thing is, as you spiral, it's not necessary that the spiral will always result in one design. No, it may actually spiral off like this, and maybe something will spiral off like that, and something will spiral off like this. And finally, you may actually end up with 4 or 5 different alternatives for the same thing. And that is what goes into the solution space. I told you there are dots over there in the solution space. Let me make a smiley of an alien there. Okay, so these dots in the solution space are the final various different alternatives you're coming up with a design. How did it come there? Because you explored the problem space along those 3 axes and explored it really, really well. And while doing that, you kept moving between problem space and solution space, and eventually, and you did that in a spiral form, and then came up with many different alternatives for in that solution space. So there you have it. That is what you mean by problem space and solution space. To summarize, a problem space is that virtual field of exploration which you need to consider. I'll be talking about in one lecture on what do you mean by user, because I didn't touch upon this. In fact, I didn't touch upon any of the axes other than just mentioning that. So we'll explore each of these topics separately. What do you mean by user or users, and what is the complexity there? And how do we really start understanding these users? Because really your empathy starts with actual human beings, which are the users over there. And then so that's the summary. So that's a problem space exploration, that you explode users, you explode site, you explode climate, and then you got an idea about what is the real thing, challenges for that particular project, and then you came up with a solution. Now this is making it very simple. Again, I'm repeating, you're actually vacillating, you're oscillating between both these things. I don't know whether to use the word vacillate or oscillate, whatever. So this is the sum and substance of this particular lecture, which is all about problem space. So once we start understanding that this is how we get into designing, this is how we really fall in love in architecture, we now have our hands full. We have kind of enveloped the large set of problems which we need to deal with, and then we will now have a solution for that particular problem which is in our hands. One step back to that question which I had asked in my earlier slide here is, what is the best design? Let me end with that. What is that best design? What is the best design? And I ask this question to all architects and architecture students, and many times they really don't know the answer. The answer is actually very simple. The first design you should consider as a possible best design is no design. Just don't design anything. Now this sounds a little odd. This is like inventing zero, the number zero. Let us try to invent the number zero first. It's really nice, very spiritual, very holy. A lot of architects over design. They look at a design problem and say, wow, I'm going to be really famous. My project will be known. But for all you know, what that architect is sitting down and doing is taking that raw material, which I told you is very rare, and then going and building something there and do what is known as over design for no rhyme or reason. Doesn't help anybody. All you have to do is just say, okay, that's the problem you're having. Okay, that's the situation which is there. Best is don't design anything. In this particular situation, let's not design anything. And this actually is the one which really saved human beings. When humans started exploring the world and started settling down in various locations, the location they selected was locations of zero design, where they didn't have to design anything, like that cave which I showed you, where they did finally make some buildings there, but that's much later in human civilization. But before that, people just sat under a tree and made love and started a family there. They got the privacy, or under a overhang of a rock, they got their privacy, and then they started a family there. That is also in one sense designing, to tell somebody that, you know what, I've explored that entire problem space. I think I should not interrupt that situation. So let's not do over designing. That is the message which I'm trying to do. So I'll see you in my next videos. I hope this is useful. I try to make each video about half an hour, and it's about 28 and a half minutes now. So this is what falling in love with architecture is all about. You really need to be immersed in the problem space. Thank you so much. I hope you all remain safe during this COVID crisis, and let's come up as better human beings. Thank you so much.